Testing, right. Okay, so I'm going to talk a bit about both test tools and test repository. Given I've only got a half-hour time slot, and both topics can easily go to an hour or so, depending on how deep you drill in and talk about different things, I thought I'd do something a bit more ad hoc and instead sort of say, right, okay, here's a quick overview, really quick overview of the two, and then drill in based on audience interest. So I've got a bunch of tabs here with various bits of content. First off, to just give them a bit of context, the Testtools is a Python testing library, so it's kind of similar to Nose or Unit Test 2. It's been around for a while, and it is the synthesis of the testing experiences that John O'Lang and myself and a number of other people have had over time. And it's got a semi-official goal of actually getting all of the stuff into upstream Python's unit test, but we have so far failed at doing this. And I'm hoping to change that soon, since I managed to get permission to spend some time on it from my manager, and there's some interest in the Python community with some of the features we've got, so that would be great. But right now, it's a Python testing library, and documentation is at testtools.readthedocs.org. The OpenStack projects until recently were largely using Nose, and they have been migrating across onto Testtools over the last, I don't know, year or so. One of the big reasons for doing that is that Testtools has some really good structures for writing tests at scale, and OpenStack with I think, what was the quote, over 1,000 active technical contributors. Actually, I mean to ask that, Tom, is that active technical contributors or just the total ever?
I don't know, it's just a number I pulled off a website.
The 1,000 developers, I know...
Technical contributors since the beginning of the project.
Right, so that's over 1,000 committers ever, and I believe at the end of the Grizzly cycle, they had 800 people commit in the last 6 months. So a fairly large proportion are still active. All of the problems you get with a large project, how do you share information, how do you keep the code agile and be able to build things, starts showing up in your test suites in a very massive way. And one of the key things Testtools has is that it's aimed at that. It's aimed at projects with tens of thousands of tests where the structure of your test matters as much or more than the structure of the rest of your code. This test code tends to be larger than the code it's covering, so you actually end up having more of a maintenance burden if you just look at how much code you've got in different places. The test repository is a test runner. So it runs the tests so it asks another test runner to run your tests for you. And that's interesting because it gives you the ability to run with different runners for different purposes. So, for example, Tempest in OpenStack is a case where we may end up writing a specific runner for the Tempest tests, but we can still have testsare sit at the front end saying, hey, please run these tests. It lets you write your UI for selecting tests, for talking about tests, annotating them, gathering performance data, storing that, data mining it once. And then you can move test runners across to get different features or deal with different languages. OpenStack's been picking up test repository at pretty much the same rate as Testtools, and the CI team at OpenStack are the ones that actually said, hey look, we'd really like to switch on to test repository because they've got a massive testing problem. I think it's over 700 test runs a day they do across all of the projects, and every one of those is essentially a DevStack instance like you guys have been bringing up on your laptops, running the full test suite for a project or running Tempest. There's a huge amount of data there, a huge amount of log files that need to be gathered, and being able to programmatically talk about what's going on and have a highly reliable environment for that is really, it's a big deal. The testing environment in OpenStack actually is front-ended by a thing called Tox, which came out of the Pi project, that group of authors. So Tox sets up a virtual env for you and will install the necessary dependencies for your project into the virtual env and then run your tests in the virtual env. So this lets you run it on a host platform with a fairly large degree of independence. And because of that, you don't actually see the fact you're using testsare most of the time. You run tox-epi27, that sets up a virtual env, goes into that, runs testsare. Testsare then runs your actual test runner, which is Testtools, and your tests run under that. So there's quite a deep chain involved as well. So that's the 30-second overview that took, I don't know, 5 minutes. Which bits are of most interest to folk here? Just, if it's not interesting, I can go get a coffee. All right, well, I'll talk about the bit that I've got the most slides for then. How about that? White pages, I love them. There, right, okay. Actually, I'm going to switch back. This works better for me. So, because frankly, I've forgotten the speaker notes for this. Right, so Test Repository is a PyPy project. It's Python. It builds on a thing called subunit, and as I said before, it runs test runners. So I ended up doing this when I was working on the Bazaar project. So Bazaar, I don't know, in 2006 or something, it was getting to the point where it was just too slow to run the tests. They were taking 15 or 20 minutes, and that's way too long to be waiting for a test run. If you're editing a line of code and you want to make sure it works, that needs to be a very fast cycle. If you can run just one test, that's tolerable, but then you still have to do this big run before you can be sure everything works and you can commit it into trunk. And latency slows down velocity. The relationship's pretty well understood. So I started writing parallelization for that, and parallelization in Python is non-trivial. You've got multiprocessing, which is kind of slow. You've got threading, which is very slow because Python has a global interpreter lock and doesn't actually free thread anything. If you don't use multiprocessing and you fork off different threads, then you've got to manage the complexity of forking separate processes, gathering them up afterwards, making sure each of them ran. So I wrote an implementation that did that, and I realized, hang on, this isn't going to be very reusable. It's stuck in the middle of BZR. There's a separate project I had sitting around called subunit, which is a serialization protocol for test activity. So if you think about something like JUnit, who here is not familiar with JUnit? Not the testing library, but the XML file, the idea that you have a file that records your test results. All right, so 2 people, you can deal. It's an XML file that says these are tests, they took this long to run, and here are the test names, and here's the outcomes. But it's XML, you have to read the whole file. There's no defined order on XML, you can't just read a little bit. You can't stream it. If you try and use that to communicate between 2 processes as tests are running, it's a horrible disaster, it just doesn't work well. And it could be interrupted. It won't be valid XML if someone's test kills off the test process and you never actually see the end of it. So subunit said, hey, let's actually have a streaming protocol that has these other properties, and you can convert that to XML to hand it off to something like Jenkins and say, yeah, I had a test run, here's some XML that describes it. So to make BZR parallelize, I took subunit and I used that between a child and parent process, and the parent just said, I'm going to run these tests, and the children went and ran them. And that worked really, really well. BZR's test grew until it took about 45 minutes to an hour to run, and I could parallelize them all onto an EC2 instance and run them in 30 seconds. So I was like, yeah, that works. And I ended up running multiple EC2 instances when I needed even more grunt. So parallelization, wonderful, but still not reusable. So testsare took all of the logic about scheduling and said, look, as long as I can enumerate the tests, I can then schedule them and use subunit to communicate about them, and it will all just hang together really, really nicely. And so it does. And that's what I've just been talking about. Other key bits of subunit I didn't mention is that it's got a well-defined grammar, so it's a feature of it that you should be able to implement it easily for any language. It's a binary protocol, which means that it's got its own checksums on each packet. It can tell if it's been corrupted. It's not subject to human editing and getting things wrong. And it understands that it will usually be running on the same output pipe as your test runner. So if other stuff turns up, as long as it isn't intermixed within a single packet, everything will be okay. And in practice, it works well. Testsare, back to testsare. So testsare needs to know how to run your test runner. Your test runner has to output subunit, but how do you run it? So this config file says to run tests, run python-m subunit.run. Subunit's the Python subunit library. And discover $list.$id option, and the next two lines say how to build those variables. And the subunit.run module is just a front end to testtools. So it wraps the testtools test execution with a subunit reporter, so that what would normally say this test starts and this test finished becomes subunit events. You can put a whole bunch of stuff in here. You can filter out some tagged tests. So one thing like the Zope test runner does, which is another test runner that speaks subunit, but Zope has this concept called layers. And the idea of a layer is that you have something that's very expensive to set up, like a database. So all your tests that need it will declare, I use this layer. And when you run it, it tells you, I'm setting up the layer, and the layer is now set up. But it's not actually a test. It's not something that you want to see when you say what tests ran. You filter it out. So those tests get tagged, the synthetic tests that send get tagged, and you can filter them out. You can control the concurrency, and the instance provision, execute, and dispose bits are really kind of interesting in a cloud environment, because they let you tell testsare how to start up a new virtual machine or a new LXC container or whatever. I mean, you put your own scripts in there, and it will call them when it wants to run tests. It will say, hey, I'm going to be running 50 different test runners in parallel. Please give me a handle for each of them so that I can execute some commands on them, and away you go. And this lets you orchestrate significant cross-machine parallelism. Without those set there, it assumes everything's going to run the local machine. So the default is just to run it right here in front of you. So testsare needs the runner to allow it to enumerate the tests, which subunit.run all takes care of, and it needs to be able to ask for some specific tests to be executed, which it does by passing in a file that lists the test IDs, one per line. To deal with things like Tempest well, I'm looking at extending this to allow it to be sort of a much richer description, so you can say these tests need to be run together. If you run this one, you must always run that one, that sort of thing, which most projects don't need, but the projects that do need it really, really need it. This is just a quick example of what it looks like to run Nova tests using testsare. So you can see here, first of all, it does a list, find out the tests there are to run, and then it runs multiple copies of the subunit actual test runner, and each temporary file there is just listing a partition of the tests. One of the things testsare does that's really quite nice is it looks at how long the tests took to run, and it groups the tests so that each partition is roughly the same amount of time. So if you've got 2 or 3 really slow tests, they won't all end up in the same test runner. Because if that happens, it's bad, right? You end up with one runner that takes 30 or 40% longer than the other runners to run. What you want to do is have all the runners work really, really hard and then stop pretty much at the same time. And it turns out most tests are pretty consistent about how long they take to run, so you can get pretty consistent results by just recording how long they took to run last time and going forward with that. This is an example of listing the tests. So it goes, you run it, it comes back with the full Python test ID for each test. Note that testsare doesn't care about this format. You can return a hex description or a UID or whatever you want. It doesn't care. It just passes it back through to the user. But the bits that are nice and the bits that are really relevant to folk who are working with OpenStack is what we'll get into now. You can ask testsare what failed the last time you ran your tests. Now, the Nova tests take a good long time to run. If we go back up here, you can see that even with significant parallelization, that's 5 minutes. Kind of slow. So being able to say, hey, what failing tests are there? What tests have I yet to fix up is really, really useful. So failing -- list will list the failing tests. If you just run teststar failing, it will show the actual output of the failed tests. So it's all captured there in the database. You can query it and look at it at your leisure. And you can also run those tests. You can say, please run just the failing tests for me. And it will query its database, see what tests are failing, and pass that through to the run plumbing for you. Now, I mentioned tests before. Sorry, Chris?
Is there any way to tell teststar to run the test which failed and also run any other tests which are running when those tests fail?
Not directly. Because what you probably want to do if you're going to do that is you want to, so Chris asked, is there some way to ask it to run the failing tests and also the tests that were ran with them that led up to the failure? Presumably you want to do it to reproduce issues, right. So there's actually a dedicated command in teststar, which I'll come back to, called analyze isolation, which does exactly that. It runs the failing scenario with all of those tests in the same partition, so it doesn't mix it up across different run instances, and it bisects to see which ones caused the failure. So I think that's pretty much everything. Here's your cake and the icing and so on. It's still got some caveats, I'll come back to that. But tied into that, right, what is a test? It really needs to be independent. It's not a test if it depends on some other thing running first. Not in the sort of unit test definition of a test. So it needs to be a single item of code that you can run with no cross dependencies, and when a test runs, it starts and it stops and it does some stuff in the middle. And you need to be able to list them. If you can't enumerate it, you can't identify that it needs to be scheduled somewhere and executed. And if you can't do that, then teststar will never run it.
How do you handle cases where your test actually modifies some of your data? You need to reset, or you need to...
Okay, so how do you handle the situation where your test modifies some global state? Well, you need something in your test environment to make sure that you reset it to a known good either at the beginning of the test, set up your environment so that you're ready for your test to run, or after the test, put it back to the way it should be. And if you don't have that, then there are lots and lots of different sorts of failures that are going to bite you. But the basic test is that as a developer, you should be able to just, without teststar in the picture, just using your normal test runner directly, run just that one test and be confident that it's going to work. Otherwise, how can you edit the test? Tempest doesn't have this property today. This makes Tempest very hard for people to work on. It's something I'm hoping to get some time to hack on, but I haven't yet. So I mentioned data mining before, and test interactions. You can have two sorts of interactions. You can have process-wide state that interacts between tests. So here's an example. If you have a test that mocks out the built-ins modules open attribute, this is a great way to really screw up the next test. Because if you don't put that open back to the way it should be, pretty much nothing that does I/O is going to work. Including, by the way, the reporting functions within your test runner that might need to report an error. So mocking out open is not the smartest thing you can do in terms of structuring a test. But there's nothing that will ever do that will cause another separate test runner instance to fail. It's completely isolated because it's within that one process. So the other form of isolation you can have in terms of modifying global state is when you're modifying a database on disk, a PostgreSQL thing, maybe you're talking to an API server. If you've actually got some external state that you're modifying, that's a lovely way you can cause interactions. So same worker and different worker. Now, the other thing you can have is that you might have things that only cause the issue while they're executing. So you can have things that cause an issue, and when if you try and do something else while that thing is executing, so cross worker, maybe you listen on a well-known port. You open port 9000 and you call listen, and two different tests try to do it at the same time, they're going to fail. But there will be no evidence that one test did it in a minute down the test run. Right? It's only a problem while that test is actually active. versus, for example, if you delete the database file that other tests are looking for, where it will be visible throughout the end of the test run. So the analysis you need to do to separate out which tests are interacting in which ways is complex. And I haven't encoded all of it as code yet. But what I do have, I think it's coming up now. Nope, okay, more data mining, slowest tests, right. So this is, again, we've got the timing for all of the tests. We can report on any individual test very easily. So this command is kind of my favorite bling in testsare. And this takes the current list of failures. It runs all of them on their own with no parallelization. So it'll just run this failure, completely new test runner process, this failure, etc. If any of those fail, then they fail on their own. Isolation's irrelevant. They're just completely broken. If any of them pass, then the only reason they failed was a sporadic failure, which could be an internal timing failure in the test, or it could be isolation. So the next thing it does is it then runs that test and all of the tests that were run in the same worker process up to it. If it passes, then it's not sure what's going on. It could be, that means it's probably either an in that test issue, so timing within the test or something, or it's a cross-test runner interaction. And although we've got the data to report on that, I haven't written any code to deal with it. But if you assume it fails, it will then bisect and run half the tests that led up to it. And find, okay, that succeeds, then try the other half, and you just keep working down until you say, okay, if you run this test and then this test fails. If you run this test on its own, it passes. So right there, that's a suspicious combination. Yeah, discard blah blah. Right, I really need to decide what style of slides I'm doing. The one where I go through really quickly, or the one where I speak to it. So yeah, I really love that. It's as a data point about how useful this was. When Nova brought in testsare, they didn't have any parallelization at the time, so their test runs were getting quite slow. Do you remember how long they were getting, Chris?
On my machine, they were taking 5-6 minutes when I went parallel.
No, without parallel.
It was, I think, around 10 to 15. It wasn't too bad.
Yeah, so it was 5 minutes with 8 cores, I think it was. So I want to say it was getting up towards half an hour. I think testsare has spoilt you.
Yeah, maybe. Short memory.
But whether it's 15 or half an hour, it's still much longer than you really want. So what happens when you don't have things being tested is they break. So as soon as they tried to bring in parallelization, everything broke. And testsare's broken, it's terrible, this is really, really hard. And I said, well, hey, hang on. All of these failures are failures due to tests that are not actually cleaning up properly after themselves. So the analyze isolation stuff was, at that point I'd been doing it by hand, but it was in my head. I was like, okay, let me turn it into an actual tool for you. And it saved the infra guys so much time just tracking everything down, because they'd just run it until they had a failure, then throw it through to the analyze isolation to get the output. And instead of having to go groveling through code trying to cross-reference, they could say, what this test does and what this test does, these interact badly. Other caveats, it doesn't handle three-way combinations. If you need to run these two tests and then this one will fail, it can't detect that at the moment. My hunch is that that's like under 5% of isolation errors, and I'm not sure about return on investment time, but question at the back.
How do you think randomising test runs on a regular basis affect that? We have a similar problem with our test run, and what often happens is I run it on my development machine and it runs in exactly the same order. So I get 2 that fail because of isolation, I fix those, and then that's all good. And then a new developer comes on, he runs it and runs it in a slightly different order, and 4 tests fail.
Yep.
So how do you think randomising orders of tests constantly help those kind of isolation problems bubble up more frequently?
So the question is, if you randomised everything every run, even though you weren't parallel, would it avoid that sort of, oh my God, I've hit the wall when you do start trying to parallelise? And I think it would, to quite a significant degree, help. Because you would, I guess, in principle, you'd have a 50% chance that the bad test is before or after you on any particular run. However, there's a couple of problems with it. One is that unless you make sure your plumbing is really robust, it's hard to reproduce the exact same order, which means it's hard to debug what went wrong when it failed. And that can be frustrating for developers who actually want to get a feature done rather than work on plumbing. Arguably, it's tests that were broken, not plumbing in the first place, but that's not always going to fly well. The second problem is that if you want to look at optimizing performance, then there's a limited set of optimizations you can do. Consider the layers example in zope.testrunner I gave before. You can't randomize things outside of the layer without incurring the cost of a teardown and bring back up of that layer. And the whole point of layers is they represent expensive things, like Selenium Test Runner or databases or whatever. So that's an interacting factor. And I've got a kind of similar thing, Test Resources, that also is aimed at the same sort of optimizations. So I think it's kind of a crutch. I think it's a great thing to have when you have it, but it's not something I ever want to depend on. I will note that once you have parallelization, which is very easy, like it's a 4-line config file and use testsare and you get parallelization right from the get-go, that gives you permutation on every single run, but it also captures exactly what ran and it gives you tools to debug it. And I talked about the API before. Oh, right, this is about being able to spin up virtual machines or containers or whatever to run your tests in. So basically, how many of them do you need? Create them, use them, get rid of them. And in the future, I'd like to have a tool that encapsulates that and holds up 5-minute to-go cards so that you can tell how long your test is going to take to run. One of the things that... Don't say that. Please don't say that. So one of the things that we don't do yet in Test Repository is online scheduling. So at the moment we calculate what the partitions are going to be, what tests will run where, based on the static data we have from the previous run. And what I think would be really, really cool is being able to do it dynamically. So if we knew we had, say, 20 machines that could run tests and we've got a whole bunch of tests and we think we know which ones are fast and which ones are slow, if we could schedule, I don't know, a minute's worth of test run on each machine. So it takes a second or so to get the test runner up and running, right? So that's maybe a 0.5% or a percent overhead in triggering that run. But then if one machine finishes a lot earlier than the others, we can give it some more work. And when unpredictable things like one machine has SSDs and the other machine has real hard disks can influence test run behavior, that rather than having to encode that in and make the scheduling algorithm much more complex, we can just make it react better when that sort of factor is in the environment. And I think that would be nice from a user perspective. I've got some plumbing I need to do that. I'd like to enhance the analyze isolation stuff to deal with concurrent workers that actually trigger cross-worker problems. I'd like to deal with 3 variable interactions. I'd also like to deal with positive interactions. So one of the ones that isn't assessed well today is when test A and test B, if you run test B on its own, it fails. So analyze isolation will say this is a genuine failure, but B will only actually pass if you also run A before it. So it's the inverse of the one this probe's for. That would be lovely to handle. And I'd love to sort of write a little query language to talk about, here's the database, describe the data you want to get out of it and go and get it. I mean, there's some basic stuff you can do today, like grep will quite happily bring back all the tests that had this particular exception in it, but it would be lovely to describe that as sort of as a MapReduce kind of API. Because I say MapReduce because we are gathering thousands of test runs in subunit format per week in the OpenStack project. So we actually have a big data problem. We should be able to get some fascinating information about what tests are flaky and how often they fail and what context they fail in, that people at the moment go, oh, something went wrong in Tempest. But if we're capturing subunit data for it, like, let's actually make use of that. And I'd like to make an HTTP repository so that rather than just capturing everything locally, you could say, I'm working on OpenStack, I'm doing a public, it's a public patch, it's not for my proprietary whatever extension. I can just feed the data from my test runs straight up to the OpenStack Foundation of information about how long they're taking, okay, also the way they're failing. So other people who see the same failure, if it's not the code you're working on, but a library dependency on that particular version of Ubuntu, suddenly you can start surfacing that sort of stuff. 5 minutes, 5 minutes, 5 minutes. What else have we got? We've got an Etherpad. So what does extra test at the bottom mean? Someone wrote extra test at the very bottom of this. I don't know what it means. I saw that before and I was like, I wonder what that means. Yeah.
I have a question. Every time you're on stack.sh, just start it up, it seems to reinstall it. Is it possible to avoid that?
There is an offline option to it. You can. I can't remember if you put that in your local RC or whether you pass it to the command line.
In local RC, you just put offline equals true.
In your local RC?
Yeah.
Yeah. So put that in the Etherpad. So yeah, that will make it a lot faster and avoid bandwidth and so on. But it should already have all of the dependencies and so on installed. It shouldn't need to download anything.
I think it's just doing it. I ran it twice and downloaded it.
All right, then there's something wacky there. That's not meant to happen. It's meant to check and find that it's up to date and then have nothing to do. Yeah, so you probably all want to set offline equals true in your local RC. I'm the next speaker though, so yes.
Yes, so the next presentation, getting started with OpenStack development, was originally going to be taken by our good friend from Canberra,
Michael. Right.
Michael Still. And yes, you can see his slide there.